Who here has played Candy Crush Saga? Okay, wow, that's awesome. A lot of people. Thank you. Any opinions on how hard that game is? Okay, that's a tougher question, I know. Opinions tend to vary as well, which is an important point. I'm a data scientist. I like to try and quantify these things. I also like to ask internet before I do anything else. This is what the internet had to say on the subject. I'm not sure if Candy Crush is really that hard. But let's consider a standard way to calculate how difficult something is. We look at how many times a piece of content, for example, a level in Candy Crush, is attempted, and we calculate what proportion of those attempts results in success. It's pretty simple. I can do that for a game, for a level, say in Farm Hero Saga, and I can do it with all the attempts on that level every date, and I can make a time series using some nice visualization tool such as this, and I'll get a chart like this. And the reason I'm starting off my talk with this is because it kind of cuts right to the heart of what I think is really fascinating and important about data science for games analytics. What's going on here? It's a super simple thing, a pass rate. What proportion of attempts result in success? But it's really noisy. There's lots of variation here. What's going on in the details that might be causing these fluctuations? I'm not going to talk so much about those today, but what I am going to talk about is what looks like a long-term trend here. Over the months that we collected these data, it looks like the pass rate is declining. That means essentially this piece of content appears to be getting harder. And no spoilers, but it's not that we changed anything about the game during that time. What this is telling us is that something about the mix of players who are accessing that content is changing over time. And so our challenge as data scientists is to use more detailed data on what's going on to really understand what drives these trends, to sort of predict how they're going to pan out for the business, and work very closely with our production teams to make sure that we put the right content in front of the right people for the future, to make sure that essentially people enjoy themselves for a long time while they're playing our games. So I'll come back to this later, but just to sort of summarize what I'm going to talk about for the next half hour, I want to start off with, I'm going to introduce King. I'm going to talk about who we are a little bit, give some context about the size of the opportunity we have to do data science here, why it's super exciting. Then I'm going to talk a bit about how we work. I'm going to talk about the data systems we have, our tech stack, some of the challenges associated with working data at our scale, the tools we use. But I'm going to spend most of the time talking about the details, what we do day to day, what sort of analysis is useful in gaining insight into the player experience. But let's start with the basics. We're a game company. Thanks for all for coming. It's a super fun place to work. Let me emphasize that. Here are some of the games we make. Here in London, I spent 2 years working on Farm Hero Saga. We're really proud of that. Some of you might have known just very recently we actually launched a second title in the Farm Hero Saga franchise, Farm Heroes Super Saga. We're super excited about that. But the important thing about all these games, and the really exciting thing for me, is that they're really a global phenomenon. They're played all over the world. Some numbers which give some context from the first quarter financial numbers this year. 463 million monthly active players of our games who played 20 billion levels in a month. It's an amazing amount of data. It's a fantastic opportunity to work with an audience this size, to run experiments with that user base, and a ton of data for us to mine and try and gain insights from. Who's doing that? We have 100 data analytics professionals about now at King, spread across 14 offices, also spread across the globe. So not only are games played globally, but King is now a global entertainment business, we like to think of ourselves as. Because that audience, that 450 plus million user base, it's bigger than the entire population of the United States of America. It's bigger than serious social graphs like Twitter. Fantastic opportunities to learn from all this stuff. Let's translate that to data, because that's what we care about here. So in a day, well, wherever you are in the world playing Candy Crush perhaps, or Farm Hero Saga, on your phone, on your browser at home or at work perhaps, when you're in contact with the internet, we collect data on what you're doing. Simple events, which maybe tell us which levels you're playing, whether you pass them or not, for example. We collect 17 billion of those every day, more or less. And actually now close to 2 terabytes of raw, just log data that comes into our systems every day. That's a serious challenge. I'll talk about some of the systems we have to handle that. And in terms of historical data, which we might want to mine and learn from, we have close to 7 petabytes stored. Again, sort of context of what we might do with that, another really big number, it's close to, we have over 1 trillion level attempts in terms of historical data to learn from. You'd have thought that we could probably learn a little bit from 1 trillion level attempts. So, well, let's see. We didn't get to that scale overnight. King's been around for quite a long time, actually. Started in 2003 as an online portal where people could play games like Candy Crush competitively. It's called skill gaming. And that was a successful business, but we really hit big success with titles when Facebook became a serious social gaming platform, Bubblewitch, Saga being our first big hit there. But we didn't stay still for long. Mobile came along and disrupted the industry again, and we were pretty quick to take our titles to mobile as well. And we launched our first games mobile in 2012, and it's no secret Candy Crush launched on mobile at the end of that year and became the global phenomenon that it is. Let's translate that to data again, because that's the experience I've had. So back before 2011, we didn't really have very much data at all. We did always track what was going on in our games. King's always been a very data-driven business, but there just really wasn't that much. But once we got successful on Facebook, we started getting large data volumes. We realized that we needed to be strategic about how we're going to handle that if we wanted to maximize the opportunity. So we invested in Hadoop. And this chart basically shows that's been an extremely valuable investment. Just time and time again, every, let's say, 6 to 8 months, as the size of our network, the size of the data coming in has scaled, we've been able to double the capacity of our cluster. We haven't had to change too much about the infrastructure. I won't say it's been painless entirely. We have a really super data analytics team who've done a super job of helping that scaling. But as a consumer, I haven't had to change too much in the way I've worked with these data over that time. It's just been really powerful. One thing I want to point out about this chart, I'll just the point down here at the end of 2012, one other very important thing happened, as well as Candy Crush launching on mobile at the end of 2012. I joined the company. I only mention that to emphasize one of the very important things that we always have to bear in mind when doing data science, that correlation does not imply causation. I'm not going to claim credit for the success of Candy Crush, but yeah, it's been an absolutely fantastic time to be part of a phenomenon. So Hadoop's been super useful in helping us scale and tackle just ingesting all this raw data. But it's high latency, it's slow, it can be a pain to work with. So our tech stack's evolved a bit. This is a very simplified version of it. There's lots of frills around the edges, but this is the basic way we work most of the time. The games generate all that raw event data. It comes through log servers into Hadoop. We use Hive that sits on top of that to get a database-like interface to all our big data. But because of the slowness there, we invested in a super fast analytics database called Exasol. And rather than processing all the raw events in Hive now, our data analytics team actually process them all through Exasol. So there's a lot of back and forth between these systems to do fast processing in Exasol where possible, but storing everything long-term in Hadoop. Well, in particular, our data analytics teams do their ETL process. That's extracting, transforming, loading the data into useful, cleaned up, aggregated forms for, let's say, for us to use for generic analysis, but also for the business. The business, for example, is always wanting to know what those 450 million odd people are doing. Are they still here? Are they sending lots of messages? Are they playing games? Which games? So aside from all the analysis that data scientists want to do, there's a lot of stuff that the business uses in terms of reports, dashboards that are available to everyone. We have systems, we use ClickView a lot. It's a dashboard reporting tool, a bit like a Tableau, some of you might know. And that all sits on Exasol now. The most important line on this chart that I haven't mentioned yet is the dashed line, which connects the data scientists back to the games. One of the most important things that data scientists do is not consuming data, but generating it. Good science requires good instrumentation. We need to make sure we measure the right stuff. We need to make sure that the tracking in our games is working robustly and reliably. We can't do anything if we haven't got good data. And just to emphasize, we're not standing still. Data continues to grow. Our ambitions to do stuff with data continue to challenge the future. New tech, which we actually have, we're always trying different products, new stuff. These are two which are actually in production at the moment. We're still finding out how we're going to use them effectively. Two Apache projects. Spark, of course, gives us a faster access to Hadoop data, basically. And Apache Flink is a real-time streaming analytics tool, which we're using already. You might have seen we have a tech blog, which I might share the link for later. We've started building data products with that. And we're super excited about the potential future applications of connecting real-time analytic, behavioral, data science tools to behaviors in the game and actions to basically improve the player experience. But that's for another talk for maybe next year. Let's see. One thing I do want to say about the data stack before I sort of move on to the more analytical stuff is that it's super important for data scientists to be really familiar with and gain mastery of these data tools. We spend a lot of our time just munging, cleaning, working with raw data, despite an awesome data analytics team doing a lot of that for us already. Yes, a lot of SQL, but lots of tips and tricks to get around its constraints. Just one quick story being another important part of looking at our content, our levels, is to understand how quickly players progress through that content. Every day, of course, we generate lots of data on which levels people are playing, whether they're passing and so on. But we also generate data on who those players are. So one of the key things that's been a big part of King's success is allowing people to play wherever they are across multiple devices without necessarily signing into a social network to do so. And so when we get new data about, it turns out player Y from a month ago is actually the same person as player X from the last week, we need to go back and historically join those histories together. That's a serious challenge. And when we first started trying to calculate player progression for our whole history, it took more than a day to process all the raw events we got in one day. That's not a good situation to be in, because then when you want to calculate the next day, you're already a little bit behind, and then again and again that sort of snowballs until you're really not delivering useful data to people in a timely fashion at all. So I won't go into the details, but now that's those jobs take I think sort of 3 odd hours. It's been quite an amazing data engineering challenge to do that. But the point is that it's really naively writing SQL queries against big data means a lot of wasted time. So we spend a lot of time mastering that stuff. That said, data scientists tend to prefer other tools. Here's actually a ClickView Dashboard, which was used to produce the chart I showed you at the beginning. It tends to be our BI devs who produce ClickView reports, but the tools are really useful for us working with the game studios. Data scientists obviously a bit more comfortable maybe using Python, R, so similar to the Bokeh app that was shown before. That's a Flask app built on Python. This is an R Shiny app. The message being that we believe it's important for data scientists here to have autonomy, flexibility to use the tools they're comfortable with to just get data to people who are going to make decisions based on it. And I'm going to talk a little bit later about some of the details of this Shiny app in particular, which gives some deeper insights into what's going on inside some of the Farm Hero Saga levels. We do a lot of number crunching, a lot of data manipulation, and so when I want to talk about what we do all day, often this is a sort of image people think of. Numbers streaming down a screen, me trying to sort of stare at them and draw some kind of insight into what on earth is going on. It's true some of the time, not necessarily super accurate. In terms of matrix analogies, which this is from, perhaps this is a better representation of what we spend our time thinking about, making decisions. So if I have to choose between option A or B, let's do an example. My friend here. Would you choose red or blue? Very important, profound decision here.
I'll go for blue.
Going for blue. Very good. So having made this profound decision, your life might be very different. wouldn't it be great to know before you had to make that important decision how things were likely to pan out depending whether you made the choice of red or blue? Well, that's the power of experimentation. That's A/B testing, and one of the things that data scientists spend a lot of time on in our studios is evangelizing essentially an experimentation culture, making sure that we run good experiments, they're well designed, we measure stuff properly from them, but also handling some of the subtleties that can arise. So we heard earlier that it's quite easy to rant about A/B testing, and there are reasons for that. Despite it being a sort of simple and powerful idea, it can be challenging. So let's have a quick look at one of the sort of challenges that we have to deal with. How does an A/B test experimental framework work? Well, we take a population of players represented by the dots here, and we split as fairly randomly as possible them into, let's say for simplicity, two equally sized groups, which we call A and B. We make sure that then group B experiences a slightly different gameplay from group A. Perhaps group B sees a slightly easier or harder level, perhaps group B sees a slightly different tutorial. Hopefully they have a better onboarding process than the people in group A. What we have to do as data scientists is come up with some sort of metric, some sort of way of quantifying whether the experience of A or B is better. Often that is something like the long-term value that group of players brings into our company. In this case, represented by RPI, the revenue per install. And what this example here suggests is that after we've run our experiment for some time, which may be, let's say, a month, we see 4% more value from Group B than Group A. Well, that sounds pretty great, right? So we probably want the business to take whatever Group B sees and make sure that everyone else sees that. But do we? So the devil can be in the details. Just looking at averages is not good enough, not from a data science perspective. Might we question these results if someone looking at the details of who was in each group discovered that two extremely wealthy, big spending players happened to fall in Group B? People like this, perhaps. I'm not saying that these people play our games, but some people spend a lot of money. This is a serious issue, and it's a serious issue not just for spending, but perhaps pretty much all metrics that we look at in our games. If you want to look at how much time people spend in our network, if you want to look at how much social messaging people do. The distributions across our player base of those things all tend to be highly skewed, which means a small number of our players contribute very disproportionately to the total amount of that thing we get. In terms of these charts here, a normal-ish distribution like the solid line would be nice and easy to handle, would allow us to run standard statistical procedures without worrying too much, where the mean is representative of the common occurrence in general, but actually what we see is much more like the dashed line. It's a log normal distribution where the variance is actually equal to the median, and the mean is strongly skewed off to the right. What can we do about this? Well, how does it affect things? What are techniques to stop us worrying about how this might affect our results? Well, whenever I see skewed distributions, I think of this guy. Does anyone know who this is? So disappointing. This is the bubblegum troll from Candy Crush. Okay, so and when I look at him, I see sort of very skewed to the right kind of tail. The important thing being that what we have three weapons in our arsenal as data scientists to defeat the bubblegum troll of skew. Number one, segmentation, as mentioned earlier. If we're worried about certain groups of players behaving differently, reacting differently to whatever experiment we're running, then let's break our player base into meaningful segments and look at how the experiment affects them all separately. Segmentation also, of course, really valuable to the business. If you come up with a meaningful segmentation of your player base, then our product team, our design teams really love that, because then they can start thinking about how to tailor the game experience to those players based on what we tell them those players are interested in. Second thing we can do is kind of improve our modeling. So if we think about an A/B test essentially, or try as a regression, what we're trying to do is predict the amount that each group spends in a test based on whether they're assigned to the test group or not, just a simple variable. But we can do better than that. We can, for example, we can apply statistical transforms to the data to better justify assumptions of normality. We can include other covariates. So we might want to put demographic information in. We might want to include, essentially in the case of trying to model spend in particular, where if we have previous information about what these people have spent, that turns out to be highly predictive and really useful to help remove biases from high spenders in the rest of the test. The third thing which I want to mention as a way to sort of handle these situations, which is growing in popularity, I'd say, at King at the moment, is to go Bayesian. Again, some of this stuff mentioned earlier, which is nice to hear. Bayesian methods can mean simply, rather than reporting, yes, this was better than that, moving to a sort of risk-reward framework where we, and our production teams really like this, where you sort of help communicate that decisions aren't clear and there's a risk maybe of the 5% chance that you'll lose 20% in bookings if you make this chance, but that's what to be balanced about against the potential rewards. It could mean working to not do A/B testing, instead move to, let's say, reinforcement learning, Bayesian bandits for certain situations, where you can explore a parameter space algorithmically. And it could mean things, things like, let's say, Bayesian bootstrapping, where you just try and really remove many distributional assumptions from your modeling. So Bayesian method, there's lots of different other techniques which we can apply to try and get better, more robust decisions from our A/B tests, essentially. And that's a really important part of our data science work. Let's come back to this, though. So, yes, we like running experiments and learning from them. But what about all that other data we've already collected? It's not necessarily an A/B test. It's just sitting there waiting to be mined. This is our pass rate. I should emphasize that a 1% pass rate, that's actually something which we're not very fond of here at King. That means it's going to take more than 100 attempts on average to pass one of our levels, and that's generally a bad player experience. Sorry if you're stuck on one of these levels. They are out there. We try not to put them out there. So does anyone have any ideas by now, maybe, of what might be changing about the player base over time that might lead to this apparent increase in difficulty for this content?
Maybe more widespread, less skillful players.
Great suggestion. And so this is what we have to do as data scientists. We have to come up with hypotheses for what might be going on, and then we need to try and justify those hypotheses through looking at other data or looking at what predictions those hypotheses make. Sure.
Why if people just more distracted because the world is getting faster, you just cancel the level because you have to get on the queue?
Yeah, so essentially, again, great point. Basically, players who are going to play our content tomorrow are not the same as the players as yesterday. And that's something which we need to try and understand and help the business predict and account for. I'm actually going to go with your hypothesis, thank you, now, because this is something which is super interesting to me. And in fact, we've actually, can prove that in our games, skill is really an important thing. And that's actually another, I find, slightly surprising thing about our games, which is perhaps not fair, but nevertheless, I did find it slightly surprising. Our games, of course, do have a lot of randomness in them. But, let's say strategy, trying to play tactically, is an important part of why people find them fun. They're not just roulette wheels. Equally, let's be fair, they're definitely not chess. There's still a lot of randomness. You still don't have total control over what happens to you in Candy Crush or Farm Hero Saga. But given that we're hypothesizing that skill is an important factor which might affect our data in that more skilled players pass through content more quickly, leaving less skilled players behind who are going to find it more difficult, what can we do to try and prove that? What's a good scientific method to try and justify that story? Well, what we can do is say, what would happen if this assumption was wrong? So if skill doesn't matter at all players are the same, they're faced with content and it's purely random, whether they pass or not, then it would be a bit like this simulation case. So here we simulate a piece of content, something which is random, you just have a 10% chance of passing it whenever you try it. That leads to predictions such as a geometric distribution for the number of attempts that it's going to take to pass that across a distribution of players. Perhaps easier to visualize in the right-hand chart here. It's a very simple prediction that no matter how many attempts you've made at this bit of content before, you've still got exactly the same probability of passing it on your next attempt. So that's what would happen if skill wasn't important. Here are a few random levels from Farm Hero Saga and the equivalent charts. These are not straight lines. Far from it, there's some quite dramatic shifts. If we look at people who've taken many attempts to this level, they are finding the pass rates much lower than people who have managed to pass in only a few attempts, which implies, at least let's say, consistency with our hypothesis that skilled people get through quickly, leaving the people who are less skilled behind. I think perhaps in this piece of content over on the left, there's this sort of long tail of people who apparently really suck at this level. I don't know if it's people's cats or what, but something weird going on there. Over on the right, though, actually, maybe looks like this piece of content is much closer to being an equitable thing. It's less clear that skill matters. So, as well as players being different, as well as us needing to understand the diversity and mix and importance of things like skill for them, we also need to understand that our content is different, and that's important to feed back to the designers as well. One other thing that I won't go into details of with this stuff, but quite a lot, not all levels, see a small increase in pass rate to start with. The two to the right being an example here, we think that's related to a learning profile. So a lot of our levels, there's some kind of trick that you need to work out in order to sort of figure out what a good strategy for tackling the level is. And that means that the first time you play the level, you might not notice that trick, and it's going to take a couple of times before you sort of switch on to that and figure out how to do it. So it gets a little bit easier once you've worked that out, but then you revert to this profile of, okay, the people who are skillful get through, and we're left with a sort of a longer tail of people who progressively struggle more and more. But this is kind of good empirical evidence that we're thinking along the right lines. What does it really mean to validate a hypothesis? I think for us to really say that through data science we're understanding stuff about our players, we have to make predictions, and we have to predict out of our sample. So that's what is done here. We've come up with some way of associating with each player a number, which might be representative of their skill, and we ask, is that predictive of their future behaviour? The actual metric we use for skill isn't very important. There are lots of ways you can come up with an idea of measuring skill. This one's a fairly simple one. You just take, nk is the number of attempts you took to pass each level k. You're currently sitting on level L, so you just sum up the total number of attempts you've taken to get there. You scale it by how many levels you've tried so far. The maximum that can be is 1 if you passed every level in one go. It doesn't really happen. That's over here on the right of this chart. People who aren't so good or are really unlucky will take lots and lots of attempts to pass their levels, and will have a very small skill metric, therefore. The actual distribution shape doesn't really matter. What does matter is that if we use this number as a predictor in a regression, then at least logarithmically, we get pretty great correlation, essentially, between what the metric on the y-axis on the right chart here is the log of how many attempts it took them to pass level 104 based on a skill metric calculated on their behaviour up to level 104. And to me, this is pretty strong evidence that this is actually, it's useful, it's predictive out of the trained data set. And obviously there's a lot more details that we can do here. One thing we can do to sort of check, and obviously checking our assumptions, sanity checking our results is an important thing as well. We can, for example, take that distribution across players of skill. We can split them into quantiles, and we can say, well, given a quantile, a grouping of players who have what we assuming is similar skill, what does their profile of distribution of number of attempts to pass a bit of content look like? And well, the right charts in particular here show that it's kind of flat again. So people who are equally skilled manage to essentially have the same probability each time to pass a bit of content as their peers. So this to me is something super interesting, and part of the data science initiative here at King is to really try and understand what are these quantities such as skill that really describe our players in a meaningful, predictive way. But it doesn't necessarily help the game team, and that's super important. We're here to make great games, and so we have to work very closely with the designers, with the producers of our games, to help them understand our results and work out how to act on them, essentially. So the last thing I'm going to talk about is to come back to that dashboard from before. So essentially, if we think about these levels that seem to be getting more and more difficult over time, well, at some point, and there's a lot of complicated analysis that goes into it, that content is just we realise it's going to be too hard and people are going to be pretty fed up with that. So the designers want to change it, make it easier. We don't want to tell them how to do that. Designers are the creative people who make our games fun. We haven't quite mastered exactly how to predict fun yet. We're trying. But we can help them. And so that's another very important part of what we do in studios here. We connect, we draw insights from our models. We use them to provide useful tools for the designers, producers, developers to make decisions, basically. What does this particular tool do? Well, it's just one example, level 6 in Farm Hero Saga. Various bits of information. It tells you that you start off with 15 moves, so you have 15 moves to try and collect a certain amount of stuff, including flowers and fruit and other fun stuff. But what this particular tab of this dashboard shows is, beyond how many out of all the attempts on this level in some period of time, how many of them resulted in success. Also, out of all those successes, how many moves did the people have left when they did pass? That's what the top chart here shows. Essentially, no one managed to pass with 15 moves still left because they only had 15 moves to start with. And a fair number of people have a few moves left when they succeed. And one of the things we can immediately do, which doesn't quite solve our problem of telling the designers how a nice way to make it easier, is that this direct data empirically gives us direct evidence of what will happen if we remove moves. So if I said there were only 14 moves to start with on this piece of content, then essentially it would be very close to the same situation, except all the people, all the attempts at this bit of content which resulted with no moves left over when they passed, would now become failures. And of course there are subtleties around the way the people play when they're close to passing and so on that change things a little bit, but actually that direct empirical link works extremely well, and our designers can, when we use this methodology to try and hit some pass rate which our designers have in mind as being appropriate for whatever they're trying to do, then it pans out very well empirically. Slightly harder to do is to go the other way. So removing moves, well, we have data on what that will do. We don't have data on what would have happened if people had actually had more moves. But then again, we can apply actually very simple methodologies to just predict that. We have enough data that we can essentially model this with some reasonable distribution. A Gaussian is a very reasonable assumption. We can take logs, fit a quadratic polynomial through it, and project out the other way. And then in the lower chart here, well, zoom in on that, you see here the predictions for what happens if you add or subtract a given number of moves to a given part of level. So the stuff below 0 is empirical, super accurate. The stuff above it is a projection, and away from a couple of moves here and there tends to be less accurate, but it's an extremely useful tool. Our designers use it a lot to try and make sure that you're not stuck on those 100 attempts to pass levels. I think that's the last thing I wanted to talk about in terms of details of what we do. So just to sort of wrap it all back together, I've talked about I think sort of 3 pillars of our data science work here on games. Working with big data, mastery of the tools that allow us to actually get stuff done quickly and efficiently, get data to people who need to make decisions. Experimentation, making sure we have a good culture of experimentation, making sure we use the right methodologies, again, to draw robust conclusions, make good decisions. And the importance of diversity of our player base, how to understand that, how to segment and how to help designers cater for the different needs of the different people in our games. If I had to summarize it all in one word, then it's all about learning. It's all about learning what it is about our players that's going to keep them having fun in our games, in our network, for the long term. That's what data science at King is. So thank you very much. Thanks much, again, David in particular as well, for the opportunity to host this fantastic event, and thank you very much everyone for coming. I hope you've enjoyed yourselves, and yeah.
Awesome.
Thanks.
Thank you. Does anyone have any questions? Hello?
You talked about capturing data for, say, pass or fail at a level. What level do you actually capture data at, the events?
So it tends to be, we don't, track every click that players make. We tend to take critical points in the player experience and collect summary data there. So we track a bit of information when you start a level. So you've clicked, I want to play this level, we'll register that. We track at the end of a level some of the details of what happened in there. And maybe key moments during a level, such as if you used an item or something exciting happened, we might track that as well.
say, so how necessary skill and game complexity influence on addictiveness and churn rates?
That's a really good question, and obviously something we're really concerned about. Yeah, trying to understand churn and what drives it is really important. And actually, slightly surprisingly and slightly disappointingly, our best understanding so far is that it doesn't have a super high impact. Certainly we know that if, for example, players who are very skillful can tackle harder content better, so people who are less skillful will be more likely to churn out at the hardest content, but that's only for really kind of super hard, difficult levels. Overall, the most important and sort of interesting thing here is that if you look at players who are, let's say, at level 1,000 in Candy Crush, where we have sort of over 2,000 levels now, there's a strong selection bias in the fact it doesn't really matter whether you were really skillful to get there or if you were just really persistent or spent a lot of money. The most defining characteristic of the fact that you're at level 1,000 in Candy Crush is that you've got there, and that actually dominates factors like whether you're likely to churn or not, which is kind of frustrating, but part of what we have to deal with. There are lots of different reasons why you might have come to the same place. Sure.
How do you handle data where you come up with outliers, like someone is using some hacks or something?
People do use hacks, although I don't know why. Our games generally aren't competitive, there are no prizes, but they do. It's probably fun. Of course, we monitor these things, particularly if people are trying to get free gold bars, which is the currency used in our games. We need to make sure that we're meeting financial regulations and other such exciting things, and we're not sort of registering cheaters as generating large revenues for us. But in general, the feeling is that our games are free to play. If people want to cheat, that's they're not negatively affecting other players, and that's kind of okay.
But does that affect your analytics? Like someone is just getting from second to third level in just 5 tries or 6 tries? Okay,
so actually that's a very good point. Yeah. So although the company might not be so bothered about it, from an analysis point, we might be really concerned. So yeah, again, it's a matter of outliers. So in terms of if we look at the A/B test example I mentioned, segmenting out different groups, one of the most basic things there to do is to clean up outliers who look like cheaters. We see, for example, lots of players playing on the same IPs is a classic thing, and that looks pretty dodgy. So actually, though, I would say we're not particularly robust at detecting cheaters in general because of the lack of the company minding about it. So whenever we do analysis, we kind of have to be pretty careful about looking at the distributions of what's going on and trying to be sensible outliers. But it is there, but not that prevalent.
Okay.
Sure.
Guy in blue. Oh, sorry, did you have on it?
Yeah, that's fine.
Okay, guy in the blue.
I was wondering about your remarks about the level of randomness, and then you said something about trying to measure how much fun people have.
Mm-hmm.
I think there might be a correlation because the fact, that I would suspect, without having any sort of data science or otherwise way to back that up, is that if people think that they have fully understood something, they will have the most fun. And if there is some randomness, which is perceived to be, or possibly anyway, an indication that there's still something to still work out, but that's what keeps them going.
Mm-hmm.
Would that be some hypothesis that you've been?
It would be, and again, this is a really fundamental part of what we do, is generate these hypotheses, lots of debate, and then try and come up with, okay, so if that is the case, how will that pan out? What can we measure? So we track some particular things about that. For example, we track if it turns there are no moves left for you on the board, for example, you get a reshuffle. And obviously, if there's lots of that happening, then that means players are being subjected to some unfortunate randomness. So we track that. We also track, on average, how many opportunities you had to make moves in a given level, for example. And both those things measure some of that, which I think is quite an important thing. It tells you about how much control players feel they have over their game. I wouldn't say that we have strong results, or I can't really confirm whether it's important or not, but that's exactly the sort of project which we're running. Yeah.
Okay. 3 more then in that case. We'll start.
Yeah, thanks for your talk. I'm quite interested in what makes a game fun. So you touched on this a little bit by speaking about pass rates and maybe a bit of randomness. Are there other elements, and do you try to customize your games to players? Because it might be different parts of the market experience different things as enjoyable.
Yeah, I mean, it's worth emphasising that generally we don't customise the game to our players. That's, a pretty strong feeling that we've got to present a fair face of this is the game. All players have to, overcome the same obstacles, however they want to do that to get through our content. But there are lots of opportunities in personalisation. I think I mentioned as well we're using real-time systems, and one of the main applications for that is maybe not in personalising the game, but in personalising our communications with the players. So we have a large CRM department, mostly based in Barcelona, who work very closely with making sure that we get the right communications to help our players when they need it. In terms of fun, so the other part of the question, there's lots of stuff. I mean, one of the things I didn't talk about now, which we spend a lot of time in the game studios working on, is trying to understand which bits of our content people like, not just in terms of difficulty, but in terms of design, in terms of different features. Across 2,000 levels in Candy Crush, across I think nearly that many in Farm as well. We have episodes which are typically about 15 to 20 levels long, and they normally have some kind of theme, which involves some particular sort of strategies that you have to get past it. And yes, players find some of those more fun than others. And quite a lot of work goes into trying to infer which of those are more fun and which aren't, and therefore which ones we should use more of, which ones we should use less. I mean, in general, the findings sort of from a high level are definitely that things which give people more control over the rewards are very possible. So if people feel they've really earned something by, say, opening flowers in Farm Hero Saga or freeing pearls from oysters, then that's a very positive feedback loop when they manage to achieve that. If we have negative blockers such as bombs, which you can't really do much about, but if you get unlucky they blow up and ruin your game, then that's actually a bit rubbish. So stuff which kind of makes sense as a player, and again that's why it's fun to work here. We have to spend a reasonable amount of time playing the games and trying to understand what might not, generating hypotheses which we can then use the data back up.
Guy with the glasses.
Hi, excellent talk. How do you balance the player's interest with the business interest? Because some people thought that it's in your interest to make a game harder, so people can spend more in game.
I think in general we hope that the players' interests are the business's interests. We're not interested in being around for a couple of years and burning players out. You can look at if you look at the history that I showed before, we've been around for a long time, and the reason we've had this success is by building a very solid, loyal player base. We want them to stay with us long term. When we get our next mega hit, we want them to still be with us. We want them to still be on our network. If they're not spending money today, then there's still a lot of potential future value in them. So we hope those things align. Of course, there's always pressure to say, run sales, run short-term events, which give people more opportunities to hopefully have some fun, also perhaps send some money. There's a lot of stuff that we can do there, but generally, long-term value comes from people having fun sticking with our network.
Yeah, we'll make this the last one, but Phil will stick around actually, so if there is anyone else. So
Yeah, very happy to take more questions afterwards, definitely.
Go with this guy.
All right, cheers. Well, thank you very much for your engaging presentation. I was fascinated at the scale at which you were doing, sort of data analytics. I was particularly interested in sort of two aspects. Firstly, I was wondering if you can elucidate about scalability of models, so particularly in the context of whether you prefer to use non-parametric models, and if you do use any parametric ones, how do you do sort of optimization of those parameters? And secondly, how do you divide work between data scientists at such a massive scale and over so many countries and stuff?
Two great questions. I can just give sort of one example for the first one. One of the ways, I showed you how you can tweak number of moves on a level to optimize its difficulty. You can also, of course, tweak other parameters of the level and do so. And so we can essentially fit sort of models which will attempt to explore a parameter maze and maximize certain properties of the level. Aside from difficulty, we're interested particularly in, say, how often players get close to passing. So it's not purely difficulty, but whether we can generate opportunities for people to feel that it's worth continuing. I won't talk about the details, but if you just try and do that sort of stuff naively, fitting it with maximum likelihood or something, then it's not going to work. But you can use things like simulated annealing, I think was mentioned before actually, and so on. There are lots of, there are always ways around to compromise, interpolate between your data instead of using all of it and so on. I don't know if that's the sort of thing you're thinking about, but that's one example of the sort of stuff we can do. We also obviously have access to lots of great resources for heavy-duty computation, GPUs, and so on if we need them. Most of the analysis we do on our laptops, though. Or well, actually, mostly we do it now on servers. But a lot of stuff is about milking our great data lake and pulling it down to a small data set which we can fit models on locally. But then we might want to push them out onto the cluster in production, for example. The second question about how we divide tasks up, how we decide what people are going to work on. Well, as I said, we have a lot of data scientists here at King. It's a fantastic community. Everyone has, of course, slightly different backgrounds, slightly different interests, so people kind of self-select as to whether they're interested in pursuing, let's say, behavioral economics versus social networks versus, I don't know, the sort of stuff I'm talking about here, sort of more, let's say, behavioral modeling. In teams, we tend to work, let's say, at least in the game studios, there are several data science teams, and there are people here who work with our marketing teams as well. That's also a big area for data science at King. But in our studios, we tend to have groups of, let's say, two to sort of 6+ data scientists working. And then it depends, if you have some people who have a more engineering background, then they're more likely to help work building nice data products. If you have people who have a more scientific background, they're more likely to work on experiments. But we think it's pretty important that all our data scientists get a fairly broad exposure to at least all the kind of basic bits of the data science toolkit. We tend to work with Agile. We tend to sort of take what the business tells us is important. We try and be a bit proactive and work out for ourselves what's important, and as a team say, well, okay, we should really do some work on this or that. I don't know, I'm not sure I'm really answering your question now, but most important thing probably from my perspective is that our data scientists have a lot of autonomy to be involved in that decision-making process themselves and to shape a vision for what how they can map their interests to what's useful for the business.